Welcome to ECS 721 Data Structures and Algorithm. This is week 3, lecture number 1. The agenda for today's lecture goes as follows. We'll implement a linked list data structures today. We'll first try to identify the data members and then the member functions. And then we're going to implement that in the Qt creator. So let's move on. A linked list is a chain of nodes. As I told you before in the previous lecture, each node contains two pieces of information, one to represent the data, and second, a pointer which link to another node in the list. A linked list is a data structure for storing a sequence of elements. Each element is stored separately in computer's RAM, but they are chained together using pointers. So it begs the question, why do we need a linked list? We already implemented or vector using dynamic arrays, and the problem with our list was that insertion in the beginning and in the middle was extremely expensive because we had to do a lot of shifting. To insert a new item in the beginning of the list, if the size of the list is 1 million, we have to shift 1 million items one spot from left to right. Similarly, if you want to remove an item from the beginning, we have to shift all the elements one spot from right to left to remove that element. So it was a massive copy step. So linked list never do a massive copy step. The running time for insertion and deletion anywhere in the list is big O of 1. That means a constant time. So that's why we are going to introduce this data structure. It has its own pros and cons we are going to talk about in the last part of the lecture. So let's move on. The very first rule of thumb you should always remember when you are implementing a linked list in any programming language, and that is you have to draw pictures of the node and move pointers here and there in order to understand that how do you have to implement, for example, a method to add an item to the beginning of the list, or a method to insert something in the middle, or maybe at the end. So we have to deal with pointers. So in order to practice that, you should go and pick up a piece of paper and a pen and draw things graphically, and then you should start coding that. So this is the first rule of thumb you should always remember. So let's identify the data members for our linked list class. The first data member, which is very important, is to represent a node using structure. So we are going to create a structure called list node because it's going to represent the node in the list. It's going to have two data members, the data of type integer and a pointer which I called next. It is of type node because it's going to store the address of such node. And we are going to give a constructor to our structured because if we want to create an object of this list node structure, we want our objects to have some initial state. It's always a good programming practice that when you are designing your class, you should do some initialization in the constructor so that your object has at least some state to begin with. So this particular constructor will take two arguments, one for the data and one for the pointer, which we call next. And we have also provided default values. And this is the syntax for doing it in C++, the assignment operator, and then the value, the default value, then comma, then the next parameter, assignment, and the default value. So our next pointer of the node will have the default value of null, and the data variable will have the default value of 0. And because the names of the local parameters and the names of the members of the node are the same, I'm going to use the this pointer. So this arrow data means that we are talking about the member of this particular list node. That's why I have color coded them so that you know that which is a data member and which is a local parameter. So the local parameters are to the right of the assignment, and the members of the list node are to the left of the assignment. And this is the representation of one single node. We also want to keep track the current size of the linked list. For that, we are going to declare a variable called size of type integer. And what this is going to do, that whenever we insert a new node to the list, we have to increment the value of this size variable by 1. And whenever we remove a node from the list, we will decrement its value by 1. So at any given time, we can easily implement a function, something called GetSize, which is going to return this size variable, representing the current size of the list. Now let's talk about the front, a pointer that's sometimes called head, or people have different nomenclature for that. I'm going to call it front. And the purpose of this pointer is going to be to always point to the front of the list. Because how do we know which is the first node in the list? So we need a marker. And for that, I've created a pointer called front of type node, which will always be pointing to the first node in the list. And in case if the list is empty, we are going to initialize the front to null, representing that there is no node in the list. So let's give our linked list class a constructor. And what this constructor is going to do is to initialize these two data members, the front to point to null and the size to be 0. Because when we create an object of our linked list class, the initial state of that object is going to be that the list is empty. In that case, the size is 0 and the front is not pointing to any node. So we will initialize front to null. Now let me talk about the AddMember function. I've given it the name so that it's clear from the name of the function that what it's going to do. And it's going to add a value or a node to the front of the list. Right, so it's going to be taking an argument, which is the value, and it's going to create a new node on the heap and pass that value to the node, to the data part of the node. So for example, if the element parameter holding the value 100, we will create a new node and we'll put 100 in the data part of that node. Then we want to update the next pointer of this node to point to the front of the list, because this AddMember function is going to add a node or a value to the front of the list. So we're gonna say, okay, initialize the next pointer of this node, which is called new node in this case, and store the address of the front. So if the front is pointing to a node in the list, that address will be assigned to the next part. So we will chain this particular node to the front of the list. And then this node has become the front now. So we have to update the front pointer and assign it the value of the new node, which is the address of this node. So this is the representation of our AddMember function. If we add one more element, so again, 2 will be inserted before the first node. If we want to insert a new element, again, that has to become the front, and front is pointing to that. So every time we add a node to the linked list class, we are going to perform these 3 steps. Now let's talk about the print method or member function, which is going to traverse the linked list, starting from the first node in the list till the last node in the list. So I have created this function called print, and I've put the word buggy here. That means it contains a bug. When you call this particular function on the object of the linked list class, it's going to print the values for the first time, but for the second time it will not. But first let's see what this particular member function does. So the first thing to do is we start from the front. So we say front does not equal to null. While front is not null, and in this case front is not null because front is pointing to a node, this condition is true. So we say, okay, get the value of the data of the front. So this is the data part of the node the front is currently pointing to. So we are going to get the value 3, and then we update the front and we say front next should be assigned to front. So what is front next? That means the node to which front is pointing gets the next value of that node.